Alright, so yeah, welcome to the live stream. I mean, you can talk if you have a microphone, but let's keep it to the questions. Otherwise, you can use the chat. So today I'm gonna hold a live stream, maybe in an hour or so, where I'll be explaining a bit more about the import-export feature. Have a little look under the hood to the export or extract Unreal Landscape node and the PNet node, the process and export node for the terrain. And I have a slideshow prepared, a bit as a guide, a bit as a explanation, because some of the concepts are a little tricky to explain. So first, I have a couple of topics I'm going to go over today. Basically, we are going to discuss the Unreal Landscape format. I already discussed this a bit in my my blog, but yeah, let's go into a little bit more detail. Then we have the extract Unreal Landscape node, the PNet node, and then the future that I have planned for the PNet node, and some of the features that I'm looking into, or will be looking into. So, first thing I want to discuss here is about the landscape texture tiles. So, the tiles that Unreal has, they have a particular resolution, right? And a particular setup. So in general, they are 16-bit fixed single-channel PNGs. Now, it is possible to use other texture types. For example, if we look at Unreal and we go to Landscape, and then we go to Import over here. Import or export, doesn't really matter. If we click on this, then you can see that we have a couple of different formats available that Unreal can support. But I found that in general, while you can import R16s and raw files, it's a bit tricky, and they also take up more space, especially the R16s, they take up a lot more space. But Unreal's terrain is generally set up as a grayscale 16-bit texture, and Unreal's landscape itself is also 16-bit. Basically, the landscape actors themselves have a height of 512 or 512 units by default. If we create a new landscape, I don't know what's down here. If we go ahead and try to create a new landscape actor like this one, its default scale will be 100 in Z, and this is 512 units. Within those 512 units, it has, if we go a bit further, 65,535 values, because it's only 16-bit. As a result, it has a certain stepping size. A 16-bit texture cannot hold a very dense height map. As a result, in Unreal, it does try to blend the height. If you don't use a fixed 16-bit texture, but instead use a floating 16-bit texture, I've noticed it starts to step. And that's when in Unreal you're going to get very obvious stepping, which, well, you don't want, because that doesn't look very nice. Like if you try to import that, you're gonna get a very obvious like staircase pattern in your terrain. Whereas a fixed version doesn't do that. So that's why I use fixed textures. Next, alternatively, we can also export out EXR files if we use Blueprint render targets. This is something that Alexander Kozlov pointed out at me when I was at EBC, in that these types of files are a different type of texture, and apparently these are the only ones that we can export from Blueprint. I tried to export PNGs and that doesn't seem to work properly, so EXRs are the only one that seems to work. But these can be used to use an Unreal Blueprint to extract out a landscape streaming proxy tile. Now I'm still looking into that. I haven't had as much time. I'm still working on other components of the toolset, such as the road post-processing. But that's something I want to look into, because having an alternative method to export out tiles is actually something I want to look into, just because of the memory issues that Unreal has alone. Like, I'll go into that a bit more later. So, a bit more about the PNG files, right? So, if you think about a PNG file, it has these amount of values internally. Now, when you import the PNG file into Houdini, it will import it with half a unit of offset. So if I import a height file into Houdini, then it won't be exactly at 0, or it might be at 0, but if you go to say the 0.5 mark of the texture, it will actually be up, depending on how many values you have in your texture. In this case, this would be a 4-bit or 2-bit texture. Very low amount of values, but if we pick a proper 16-bit texture, then, well, you're going to get these amount of values, and then each value will be offset by that amount. That's a very small value because of the E number here, -6, so 0.00006 zeros. But if we were to multiply that by the actual height of the terrain, and then half the offset, then we would get an offset of, let's say, 7 to 8 millimeters, which is not a whole lot, mind you. And actually, and any changes that fall under this, rather, that we have, any noise, will be ignored when you import this back into Unreal, because Unreal simply cannot handle anything smaller than this when it comes to noise. So that's the main trick I'm using. If there is any kind of noise that takes place in my system, it usually falls below these thresholds, and then Unreal ignores it. It just snaps it back to the correct value. But that's the important part, is that because we're using these PNGs, we need to export it the same way as we import it. And that's where the main trickery comes in. Because Unreal landscapes have a couple of quirks to them. The main one is that, for example, the pixels themselves in Unreal are center of pixel, whereas in Houdini they are corner of pixel. Or at least, if we think about landscapes, like traditional landscapes in Unreal, they would basically be these giant tiles, right? They could be 2 kilometers in size, 4 kilometers in size. If you want to line up two of them next to each other, like with the old world composition system, right, in Unreal 4, then you would have a situation where the tiles need to be completely flush with one another, attached at the edges. In that context, it makes sense to use corner of pixel. Basically, take the landscape in Unreal, scale it up just a tiny amount, just to make sure that these tiles sit right on top of each other. Or extend one tile further by 1 pixel, right? Make it just slightly larger, just to make sure that it connects up to the next tile. However, this doesn't help much with streaming proxies, because streaming proxies already do this for us. And they expect very specific resolutions. So here's what I mean. If we look at a streaming proxy tile, it's kind of like this, where we have these tiles, and they are always 1 pixel smaller than the actual space they take up. And they do that by offsetting themselves to the center of the space they're supposed to take up, right? And then in between, you get this gap. This is what you would see if you were to import the streaming proxy landscapes into Houdini, into the same configuration as they are in Unreal. So on the right, you see these gray areas. Those are tiles. Imagine this is like the corner area of a tile here. And this red line is actually where the tiles are supposed to interconnect. Now you could also consider that this red line is offset to, say, this corner here, perhaps. So it's more like on, say, the left bottom edge of every tile. But for simplicity's sake, let's say it's in the middle. Now the problem is that if you were to do this with regular landscapes, you would get 1 pixel gaps in between everything. That's how the old system used to work. It would stretch these tiles out, make them a bit bigger to overlap this gap. However, in streaming proxies, that's not how it works, because streaming proxies automatically interpolate between these gaps. So if we have a tile here and a tile there, it will connect that up. It's very similar to how some of the other systems in Unreal sorry, in Houdini work, let me see, where is this node? The tile splice here. So here we have a situation where we have these tiles and their pixel count, right, in this case is 1020. So this is if you have a section size of 255 inside of Unreal. And then in this case we have a tile that's about 1 kilometer in size. We get this pixel count. So we have a couple of different tiles here, and they're all being loaded by default using the center of pixel mode. It's easier to see if I do top down. And then let's bring the grid up. So right now, if I have it in center of pixel mode, you see how it's literally sitting on that grid line. That's the edge of this tile. It's basically putting this tile inside the 1 by 1 kilometer space, because I have scaled this tile in Unreal in such a way that the tile itself sits exactly in between that space, but it's not completely on the edge of that tile, you see. It's half a pixel out. If we take these tiles together like this, like they are in a streaming proxy tile, and we combine them using a tile splice, then it fills those gaps. Now this does change the vertex count, or rather, it keeps the pixel count. But if we split it up, we basically get these 4 tiles back, right? So only split, no, height field split. Let's split this up into 2 by 2. And we want to do no overlap, I believe. Let me see. That should be it. Okay, right. Let's do that. There. Alright, so now you can see I'm basically getting my tiles back. If I do overlap, then it will add 1 extra pixel here at the end, but that's basically a pixel that gets stretched out. This pixel that you see that gets added here, if I only extract 1 tile, it's kind of like an extrapolation, and we don't want that because that's junk data. That's basically data that isn't quite what we would get in Unreal. So that's why I just keep my tiles in the same configuration as they would be inside of Unreal. If I select any of these tiles here, then in Unreal they look like they connect at the edges. But in fact, the pixels themselves are not on this line. They are a bit to the left and a bit to the right, and then it just interpolates between them. That's what center of pixel is about, right? Now, another thing we need to make sure of is that when we import and export our data, we don't create offsets. So here, in this case, we have a situation where because I'm not accounting for the height changes that occur with a PNG, right? And I try to import the data using the Houdini engine, and then I import the data from a height field file, and I compare them. I get this problem where the red indicates a, in this case, an upward offset, and the blue indicates a downward offset. It's basically because of that half a pixel offset in the height. So I have to compensate for that using the equation here. And then you can see everything turns gray. Gray in this case, in my visualizer, indicates that there's no difference. And I've set this to a very, very small value, like 0.001 or something. Smaller than what the PNG precision is, so it should be safe if it's gray. If it's blue, it's lower. If it's red, it's higher. But inside our terraforming, like this area here is being terraformed, this red area, that's fine, because we are actively changing that, but we don't want to change anything else. And this is important because I'm basically bringing the data back and forth between Unreal and Houdini, and I don't want to accumulate half a height field, half a PNG unit's height every single time I do that, right? We don't want to accumulate basically errors into our data, or noise for that matter. So, like I was saying, this tile splice I mentioned is basically a lossless process as long as the resolution is correct, the resolution of your landscape. And then we can use the tile split and tile splice to break it apart and connect it back together again. This works if it's done right. However, the Houdini engine always adds an extra vertex when importing. So it effectively adds an extra pixel at the end of every tile. So if the tile starts at 0, 0, anywhere it's on the other end of the tile, so let's say a tile is 1020 units wide and high, then it's going to make it 1021. Okay, or in case we use a streaming proxy landscape and we import that thing as a whole into Houdini, then it's going to turn a height field of 8160 pixels into 8161. And that pixel at the end is basically similar to what I was showing you here with what the splice does, or sorry, the split, where it just adds that extra pixel at the end. Now there is a reason for this, and I suspect it's actually something that Unreal does internally. But unfortunately, and this is where it kind of gets tricky, when you try to import something into Unreal's tiles, it only accepts the landscape pixel resolution. And anything over that is just going to resize, which is probably intentional, but a little dumb. Because the problem that I found is that if I try to import a tile with the actual resolution of the tile, or like let's say the vertex resolution, if I go to, let me see, new, right? So notice here how, let's see, where were we? Import from file, yeah. Let me import a blank tile here. Tiles, initial tiles, let me grab some tiles here, right? So this is a new landscape. Now it's going to detect the height map resolution of 6120 by 8160. The amount of vertices this thing has is 1 extra. So that's the extra vertice. That's what I mean with center of pixel. It counts this many pixels, but this many vertices, which makes sense, right? Because a pixel is basically a square, and the vertices are the corners of that square. So if we have this amount of squares, then we have this amount of corners of the squares. Now when I try to import to a landscape, on the other hand, using the import function, I've noticed that in some cases, and I don't have a good example here, unfortunately, but basically I think that the actual landscape itself is either 1 pixel larger, or the last vertice is not accounted to any pixel. So as a result, if I were to stamp a change into this terrain using this height map, right, it will not affect the last pixel on the edge of this height field. Now I don't know if that's because the entire stamp that we see here needs to be offset by like half a pixel forward. Frankly, I've not tested that. But the main problem is that it doesn't affect the whole landscape. It only affects everything but that last pixel at the end. And if we use individual tiles, so not streaming proxy tiles, it will happen to every single tile in our landscape. So importing a texture to a tile doesn't actually change the last pixel on that tile, which is really annoying. I don't know if this is a bug or if I'm just not doing something right here, if I need to offset it, but frankly, this tool is not the easiest to use. Because while I can move this thing, there is no snapping, there is no number input, at least not as far as I found, right? So I can reset this thing to the import location, but if I try to offset it by like half a pixel, I have to do it from top down in wireframe. It's a bit annoying. So I don't try to mess with this, because that's too much of an error. That's too easy to make a mistake, right? Now, the benefit of streaming proxies is we don't have to worry about this too much, because streaming proxies only do this at the very edge of the terrain. And something I have done, and this is also a pretty useful thing to do in general, is I have taken the entire outer boundary of my landscape and I've flattened it down to 0. By flattening the outer edges to 0, I accomplish two things. One, because this final pixel at the edge of our landscape will never be affected, it will always stay at 0, right? Okay, that's one. It might be able to push it up if we like start sculpting or do something, but we can always, you know, reapply this effect to the outer edges, so that's one thing. The second is that it blocks light. It casts shadows, rather, because any light that comes in from the side of our terrain, like sunlight, if we didn't have this barrier of some kind here, we would basically see sunlight shine through our terrain. Now, I don't know how that works with Lumen, but I know that it doesn't work for the default lighting, so that's one of the other reasons I do that. And it works perfectly fine, because it actually gets around the entire issue that the final pixel will never be properly updated. If you ever need to, you can always sculpt that final pixel by hand, but the stamping system inside Unreal doesn't seem to directly affect it. And when you're thinking, oh, well, why then not just simply feed it a texture with 1 pixel more, right? Well, if I do that, this thing is going to tell me, your resolution doesn't match the landscape. And it will just try to downscale it down to match this resolution. At which point we get a sampling conflict, because we have 1 pixel more than the other. And that might cause slight height changes in our terrain. We don't want that, right? We don't want to have any conflicts in our we don't want any conflicts in our height map, because then we start introducing errors like these. So that's the main gist of that. It's a bit tricky to understand, but the main thing is that Unreal doesn't seem to import to the whole tile. It imports to everything but the last pixel by default. And there's another reason I put the landscape at the center of the world, is because that way at least my stamp and everything should be in the correct position. Yeah. Now, I am looking into an alternate way to import directly to a streaming proxy tile, but even then we still need to control where this brush goes. And supposedly it's possible to do this with blueprints. And with the Houdini engine. I had some advice from someone. I mentioned his name just now. I'll cover that in a bit. But I'm going to be looking into that as an alternative method to apply our terrain. So we don't have to go through the import method in Unreal, like this part, and import every single one of our tiles by hand. But, well, I'm not there yet. I will have to further develop that portion. Alright, let's move on. So the way how we get around this issue is by conforming the terrain data that we can import from Unreal using the Houdini engine by deleting that final pixel and then offsetting the entire landscape, or the other way around. Either way, we need to remove this final pixel and then offset the entire landscape over by half a pixel, so we compensate for the lack of that pixel over there. If we go to, let me see, on Houdini. Right, so this is basically a scene where I've exported out my terrain from Unreal. And this is the Extract Unreal Landscape node. Now, the Extract Unreal Landscape node, let me just get to that here, has the ability to extract out the landscape as a whole. And it does so, in a nutshell, it corrects the offset issues of the landscape import process of Unreal to Houdini using the Houdini engine. Not using tiles, right, but actually using the Houdini engine. It recomposites the height map from its own edit layers to give you a correct height map, because I've noticed that the actual height that you see in Unreal right? This visible height is actually not the actual height that you would get if you were to combine all the edit layers. If I go to the edit layers of my terrain here, right, let's go to sculpting mode. And I look at them like this, okay? This looks like the final terrain. But that's only because all my edit layers are currently active and they're all set to an opacity of 1. If I were to take my procedural layer here and I set this one to 0, then while this layer is still active, my height for that is different. It's changed. It's gone. And then basically all these layers together, now there's probably not much in the alpha layer, but if I set that to 0, then all the terraforming of that layer will be gone as well. I don't think that's in this layer. But the basic idea is that each layer contains a certain level of terraforming. And then Unreal shows you an interpolation of those. If I go and simply disable my procedural layer altogether, it's the same as setting the alpha to 0, but it basically recomputes this virtual height map that you see here. That's why you get that message there. It's busy computing it again. If I click it again, you'll probably see it again. Video memory is exhausted. Yeah, it's one of the issues. One of the issues with Unreal is that it uses a ton of video memory for landscape manipulation, especially for larger landscapes like this. And, well, this basically means that the landscape we see is a virtual texture representation of the height map. It's not the actual height map. It's a height map that's a composite of all these 4 layers. But I've noticed that by importing this particular height map, which is imported by the Houdini engine, by the way, it's not exactly the same as the accumulated height map of these 4 layers together, which are also imported by the Houdini engine. It imports these 4 layers, in this case, all the materials, at least the ones that have layer infos, and it imports the final height map called height. What I need to do inside my tool, however, in order to make sure that I have an exact version of the height map, right, not this approximation that Unreal creates that we see in the screen, but an exact version that matches the actual height of the terrain, I need to recomposite it, which means I need to go in here, find out how many layers I have, filter them out, so I can sort out, say, which layers I have, and then I use this process, which is basically a copy of one of the other nodes here. I think it's a height fields layer then, yeah. Right, so I basically copied part of this network because height fields in Unreal are effectively a form of volume, okay? And when they created height fields, a lot of these height field nodes are basically constrained and adjusted volume nodes. VDBs weren't native in Houdini until maybe Houdini 13, right? So I think 2013 or yeah, around that time they were added. So before that point, it was just volumes. Now, Houdini volumes have their own set of nodes, right? So you have the volume nodes, all of these. So we have the different volume nodes, and the height field nodes internally have these nodes in there. So if we bring that height field layer back, then inside of here, we do have some other height field nodes, but again, we can go inside those if we actually render them, that is. Let me just click on that, because it won't show the node internally until you have at least rendered it. You can again see we have a volume mix in there. Let me see, anything else? Rename nodes, blast node that talk to the individual layer names. So yeah, all these height field nodes are effectively volume nodes in disguise. Which is fine, because that means that we can recreate that process, right? Now, if there's one issue with height fields, that yes, we can talk to them using, for example, a height field wrangle, which is very powerful. But the height field wrangle cannot talk to individual layers. So here we have, assuming I actually have some data here. Let's see, like you. So this one can talk to, say, the height layer, if I know the name of the height layer. But if I do not know the name of the height layer, that's a problem, right? If I don't know what the name of, say, this layer is, the base layer or whatever, I can either copy this layer to a name I do expect and then assign that. It's possible. You can use a height field copy and then copy it to a layer like work layer 1, work layer 2, and then you can talk to it directly and then later copy it back to the layer that you want to. Or alternatively, you have to go in and talk to the layer using a attribute or a hscript command. Basically, we can say the name attribute is a particular name. And then we can use things like this volume mix here to affect this layer. So here I'm basically adding together in sequence each edit layer one by one, including that offset that I mentioned earlier, which is basically the offset for the PNG files, right? The 16-bit half a unit offset. So that's applied here, and that's taken into account right there. So this basically takes all these layers, recomposites them, makes sure that we have a final representation of our height field, which is exactly the addition of all the edit layers together. At which point we have an actual accurate representation of our terrain. Without that, we would have this inaccurate import from Unreal, and that won't help us. Also, of course, if we were to import the individual layers using texture files, for example, we also need to recomposite them all together to get the final height map, because Unreal will not give you a combined edit layer, if you will. You can export these edit layers. Maybe there's a way to export out the combination, actually. If I go to export, export single file. No, that's not it. Will partition only when true export the landscape as a single file. Okay, no, this will just export it without the tiles. This just exports the entire landscape as a whole, I think. Export selected edit layer. If oh, here it is. This will export out the blended result, but I do believe that this will be an inaccurate result. If we turn this off, then we export everything out as a whole, so everything combined, all layers combined. But I found that's inaccurate, so that's why I do the compositing. So next to that, it also assigns some attributes to describe the landscape scale. That's in part what this system does here. I mean, this is actually also a means for me to give information to the user, to tell them the exact size and position that the landscape needs to be set in. Because another difference between Unreal and Houdini is that landscapes in Unreal have their pivot at the far corner. And in Houdini, it's in the middle of the tile. Which means that once you import this tile into Houdini, it actually has to be offset by half the tile's depth and width, right? Otherwise, it won't be in the right place. That's what this entire bounding box is about, this blue bounding box. It helps us identify what the actual landscape is that Unreal sees, or Houdini sees from Unreal. This red outline here, this red line, it actually is also inside this blue line. If we go dive in. Basically, if these overlap, it's in the right place. Now I do currently assume that the landscape is going to be at the center of the world. I don't have full support yet for offsetting it. Now there is a trick we can use called a world offset, where we basically take the position in the world and we offset it back to sort of make Houdini think it is at world center. That's actually a feature that's partially in the Houdini engine as well. We cannot access that from here. If we go to any Houdini asset, we go to, let's see, It's not there. Trying to see if I can find a curve input or something. Keep world transform. Keep world transform supposed to help the landscape keep its original location in the world when it's imported into Houdini. Without that, it might import it to world center. Now, that's a whole other story. I'm not going to dive too far into that, but I might cover it in the future, in another stream or something, or maybe on the blog. But yeah, if you import an object from Unreal, it can have two types of transforms. Either it can be at the center of the world for Houdini to see, or it can be in the offset position that's relative to Unreal's position in the world, right? And depending on where your tool is, maybe you want your tool to always assume that the object is at the center of the world, as opposed to in Unreal's space, right? You don't want that offset. That's what this is about. And then finally, like I said, yeah, I want to provide useful feedback to the user. So this is for Houdini, this is for the user. If we don't have that, then we're gonna have issues. The landscape might not be the right size, it might not be scaled correctly. So I wanted to make it as simple as possible for the user, so they know what to set their landscape to make it work correctly with my tool. But also to make sure all the tiles are, for example, 1 kilometer in dimension, depending on what you want, right? So that's something we can configure here. There's actually a couple of changes that I've made to this tool. I'll be posting that in the next upload as well. One of them is, for example, you can now scale the terrain up to extreme sizes. If we set it to this number, then it will tell me now that, well, you should use these values instead, and our terrain will be massive. But this is more suitable for say flight simulators or something, because if we scale our landscape up 16 times, as opposed to this is basically 1 pixel per meter, right? This would be 16 meters per pixel. So we'd be scaling this thing up 16 times. We would have a massive landscape, but that would only be suitable for flight simulators, because even a 2 meters per pixel is actually too low resolution for a shooter or something. Or you have to keep relatively shallow terrain. It's possible, but yeah, there's some limitations there. Alright, so some of the pros and cons to the approach that I have here. It's quite foolproof. I've tried to make this as foolproof as possible, and it can quickly be reapplied. The entire export process can be kept with the same settings. There's only a couple settings anyway. And you can bring it into Houdini. You can redo your stamping. You can export it out. Simple. And it also provides an exact snapshot of the entire terrain for Houdini to use. So, you know, again, we have the entire terrain. We do have to work with the entire terrain all the time, which is a somewhat limiting factor. There's some other limiting factors I have no control over, like creating a landscape of a certain given size might make you run out of video memory. If you try to go to 16 by 16 kilometers, for example, at 1 meter precision and with a relatively complex terrain material, you'll run out of video memory really quick. I've only found I can go to 16 by 16 if I have almost no detail in my material. And that's with a 24 gigabyte graphics card, which is insane, but okay. There's something Unreal is doing about this right now, or at least I've saw on the UDN. They are looking into asynchronously importing and creating landscapes. When that's supported, I will update this process further, but more about that in a minute. On the downside, however, sampling the terrain does take a few minutes. So what it does internally is that when I use this tool, this extract tool, it loads the entire height field into memory, which also means you need a decent amount of memory, right? That's then stored inside the Houdini engine's memory. Effectively, it will import this, or rather, if we go out a bit, it's importing this guy. It basically takes a height field node, unlocks it, goes inside, rewrites it, and then it locks these height field volumes in. This is why I have no control over how the Houdini engine imports height fields. It basically just gives me a volume node with locked data. This is just an empty volume node, but it has data in it that's been locked in memory. That's how the Houdini engine imports this data. SideFX is working on updating the entire import process for pretty much everything they're doing. There's a presentation about this to make it more streamlined with how Unreal operates. But that aside, this is how it currently works. If SideFX changes this process, I will update my system as well. So where were we? Right. Now it also requires the entire terrain to be loaded and at world center in order to make a snapshot. If you don't load the entire terrain, then the Houdini engine will not see parts of the terrain. And right now my terrain needs to be at world center, which means that it will be offset, and then there's some issues with positioning. So I can maybe fix this if I need to. I might be able to allow it to only import parts of the terrain, but then I would have to composite that together with a full version of the terrain or something. So that's something I might be looking into, but currently not quite yet. And then we also have video memory limits. So like I said, the size of your landscape, depending on the size of your landscape and the amount of video memory it takes to load it, it's more than exponential to the power of 2. It's probably more like to the power of 2.5 or something, which is quite bad. The larger your landscape, the more video memory you need, and once you go over your limits of your graphics card, Unreal simply crashes, right? So there's limitations to how big we can go right now. My current plan is to support an alternative method to import landscape tiles, right? So there's, like I said, 2 candidates for this. The first one is for me to import only a selection of the tiles, so only loading a subset of our landscape streaming proxy. So right now I have everything loaded right now, but I could go and maybe only load this region, unload that section, and then assuming, of course, I don't have things pinned in here, and this is because I have saving enabled. Hold on. Let me just go here, reload that. Right. If your tiles are not saved, you cannot unpin them. And pinning basically means they stay in memory. If a tile's not saved, it cannot unload it. So we can go to save everything. Just to demonstrate quickly. Come on. Save all. Okay. So now if I try to unload this, okay, so it has properly unloaded it. It could potentially pin them. Then you have to click on this pin here to get rid of it. Right now they're unpinned, so that's fine. But you can see that only right now it's only got maybe half the map loaded, right? Because this center tile's loaded as well. If we unload that, we will only load this section of the map. By doing so, we open up the task manager here. Let's go here. You can see here is my dedicated GPU memory. Now it's maybe not as bad as this, but if I go and save or I go do other stuff, this will probably drop. But basically this is the amount of stuff that's being loaded to memory. All these textures that are being loaded for the terrain, they're being loaded and they're stored in this memory here. Plus, it also uses my regular memory on my system as well. So over time, this will drop, especially if I go out of Unreal and I come back. But if you actually load your landscape tool, it has to load all this data into memory. Now, if I were to try to export right now this terrain, it is going to try and export only half the map. If you try to import, to half your map, it will, well, you'll also have some issues as well. So it's possible, potentially, but Unreal only allows you to select all the files in a folder at once, if you understand what I mean, right? If I go to any of these tiles, like, let's go to my procedural layer is the one I'm using. If I select any of these, I'm basically importing the entire batch. And that's how Unreal works. If we try to import a smaller amount of tiles, we'd effectively have to lower the amount of tiles in this folder, because I cannot control which ones it imports. It will either import everything or nothing at all. And if we have additional tiles in here with additional tile numbers, it will just assume the landscape is bigger. It's not very smart about it. So if I try to import this, I haven't actually tried importing it to only a part of the map. Maybe I should try that, frankly. But yeah, that's that thing, right? We can maybe try to import it right now, and I have no idea how it's going to respond. So give it a go and hope it doesn't blow up. Okay, either it did nothing or it actually just stamped on the available tiles. That's not a bad thing per se if it works like that, frankly, because that would mean we could potentially only stomp to a part of the map. But even so, it's not an easy system to work with. But okay, so now that's how virtual memory technically works, right? Also, anything that's currently stored in memory and not saved to disk will also take up more virtual memory, so there's all kinds of limits. Right. The alternate process would be a blueprint-based exporter. Like I said, Alexander pointed me to this, where you can basically create a blueprint that can load in the streaming proxy tiles, their layers, and then export out this data to texture files. So far, we've only been able to export it out to EXR files as an RBG channel, which has its own issues, but it's not something you can't overcome. Something I might look into as well. Alright, so next, let's have a quick look at the PNet node, the process and export node. So this node is basically the node that allows us to well, bring all the data that we exported from Unreal into Houdini. It handles compositing for the landscape as well, for the different layers and whatever changes we make to it. And the idea again is to make it very simple to apply changes to your landscape from Houdini, and then have this node handle all the logistics of compositing the edit layers together, managing the data, managing the materials and the settings and the attributes. It all sets everything up and it all exports everything. So as long as you don't make any, mess in between the import and export process, you should be good to go. Next to that also is the ability to preview your layers before export, and well, it exports the height map data to Unreal compatible tiles. Technically it's even able to add your own layers, ones that weren't part of the Unreal batch, because ultimately we are not importing this directly to Unreal, we are creating a tile set, right? So we're basically creating a bunch of tiles in their respective folders that we can then manually import to Unreal. So that's pretty straightforward. And then next, inside the PNet node, I have a sub node, a sub asset called the batch tile exporter. This component basically it cuts the height field layers into tiles and it exports the desired tile, right? And I run this inside the PDG in order to process through all the layers and through all the tiles. So it's very simple. We take all the layers, all their height field layers, and then each one's effectively a primitive. And then this node grabs a tile based on a tile number, right? And it cuts that one out and then it exports it. So we just run this, I don't know, a few thousand times, depending on the size of your landscape, depending on how many layers you want to export. And we, this way, push out all the tiles. Now, in order to make this work, I did have to modify the default Houdini height field output sop. Basically, the default node here in Houdini has some Python in it. And for some reason, the height field output node here, for some reason the height field output node has some Python code in here. I'm not sure where it is. Let me see. Not there. Oh, right there. So inside this vopcop, there's some Python code that basically interfaces between the different modes of the tool. I don't need to use every single mode of this exporter. I only need the one that outputs a single tile. I don't need anything that handles like you know, batch processes, like multiple tiles, like sequences of renders or something. So I had to rip this out because for some reason the PDG doesn't like Python code. I've noticed that if you try to execute Python code inside of a node that the PDG is trying to run, it simply just stops, or it doesn't execute it. Someone told me it's possible. I have not found a way to make it work. I've tried this several times. So the PDG, yeah, it just has that issue. So I had to get around that. I had to rip it out and I had to make my own version of it. So let me go to the other scene here. So here is my process and export node, right? Let's go inside. This is the locked node. Normally you can't see inside of that, but I have the version, so I can. And I just unlock it so I can actually view inside this network. Give me a sec. Okay. Right. So this is basically the process that it runs when it runs the tiles, right? So it takes the terrain tiles, it creates a wedge for every layer, and it creates or rather for every tile in X and Y, and then it just outputs for every single tile this processor. And that's what outputs all these tiles. It's a very fast process, it's very lightweight, you can multi-thread it. So if you have a PC with a decent amount of cores, then yeah, it won't take very long. So let me quickly go into the node. So there's a couple of systems inside this node. You'll notice a couple of repeating components. Up here, I sampled the landscape for all its layers. Basically, we do get the layers from Unreal coming in. So here's one of my caches. We have basically one of the landscapes imported. Assuming it loads. Okay, that's fun. Wait a sec. Here we go. Right. So we do get all these layers that come in from Unreal. And I also have some attributes that I've pushed inside my point attributes in this case. This comes from the extract node, right? This is a file that's extracted by the extractor, this guy. And then I basically just get this height field, and I get a height field with a ton of layers in it, depending on, you know, which layers I was exporting out, which material layers in Unreal had layer data on them. Plus, like I said, we have the height map. This is what you see by default, by the way. That's the composite height map from Unreal. That's not completely accurate. And then internally, we also have the, let's see, landscape layer, in this case the name of each layer. So we have the base layer, macro layer, procedural layer, micro layer. The layers are fed into this node by the same order they are in Unreal. So that's a good thing. The bad thing is that a lot of processes in Houdini like to do things alphabetically. So we have to first figure out what the order of these layers is and then assign that to an attribute, because otherwise it's very easy to get things mixed up. We don't want that. So here, for example, I take the primitive number and I store it as a layer order, right? Also, I try to make sure I rename some of my layers, just to make sure my names are properly set up. I don't want to have any spaces in my naming. I want underscores. So yeah, there's some of that cleaning going on. This system here grabs the layers, outputs them as point information. So every layer is represented as a point, so I can easily filter that and also process it. So let me see here. this is a function that I don't think I'm still using. No, it is. Sorry, this is because I had to rip parts of the system out to make it work with the black boxed assets, but that's another topic entirely. Okay, so here basically I filter out all my landscape layers. So these are the only layers that have landscape height map data, not the height layer, but just these guys. Let me just see. There they are. And their order as well. Same thing for the materials as well. I basically go in and I assign all this information from these extracts. Basically, I get this information, I can sort the layers, and then I can feed it to this part here. And this part basically composites every layer. We have one for the base layer, pre-procedural layer, the procedural layer, and the post-procedural. If you've been following the workshop, you know what I'm talking about. This is basically the individual layers of my system that I can then represent as a composite, right? So the final one here is basically the landscape with all layers combined. If I go to this guy, oh, that's, sorry, let's go to this guy. That would be the height map that you get with all layers combined. If we go to maybe an earlier layer, then you see that the roads have disappeared, right? So each of these is basically a state of our terrain with certain edit layers applied, which we can then export out. That's one option. Then this component here is my compositor. Now, the compositor is used when we have layer conflicts. So this is not something I've covered very deeply inside the workshop. But basically, let's say we have this situation where we have two different layers combining. If we were to apply our procedural changes, like this dark blue line to this light blue line, we would get, well, this effect here. Let's say we have some manual terrain here. I think this was I had a different image before that. We had a house on top of this yellow section. This is a post-procedural bit of painting, right? Now, the problem is that if we push a procedural layer in between that, in between the blue line and the yellow line, then it turns this gray line into this result, this colored result. Basically, we make our house inside the terrain, right? So what we need to do is then composite it to detect where we don't want this to happen, and then restore that terrain back to the way it used to be. So we don't affect the area around our house, but we do terraform the rest. This is one of the possible compositing that we can do. So there are 5 types of compositing options inside the system. We can disable it entirely. We can make subsequent layers auto mask our modifications to the height field. We can do the opposite, so modifications auto mask the subsequent layers, basically push through any changes regardless of whatever was there, effectively erasing any hand painting or subsequent changes in other layers. We can keep the maximum between layers or the minimum. That might be useful in some cases, but I find mostly maximum is useful. Like if you have 2 hills intersecting, like we terraform in a hill and we already have one in a layer, they will intersect and then they will basically, you know, merge together as opposed to try to mask each other out. So here's a little quick overview. So this is basically what the default behavior would be like, right? We add this blue layer, and then as a result, the house is now underground. So that's the default behavior of Unreal. This one is where we make subsequent layers auto mask our modification. This will erase the modification when subsequent layers are making changes to the height field. So in this case, we can think of, let's say, like in this case, for example, we have a situation where I'm using an exclude mask, where this section of the change that I'm making, this gully, this dark red area, right, is not applied. So we can basically prevent it from making changes in areas where we don't want it to, where we already have something. Like if we hand painted something in place, they will prevent our own modifications from taking root. On the other hand, we can do the opposite. Like I said, we can basically push through our changes and make subsequent layers ignore that. You can also use the composite mask in this context. In this case, if we have a subsequent layer and that layer is making some form of changes and we don't want that to be on top of our procedural changes, like let's say we have some hand sculpting somewhere and we want to push a road through some area, we can either use a composite mask on the area and then override that manual sculpting, or we can just tell it to remove any manual sculpting altogether, as long as there is a change by a modification we've made. And then finally we have minimum maximum. So like I mentioned, if we have a hill that already existed and then our own modification, in this case here on the right, we are auto masking with a subsequent layer. This area here is a subsequent layer. This is our modification. You can notice how our modification is basically erased. It blends down, so it doesn't affect our existing layer. Or in this case, where we have maximum, it basically interfaces both of them, and it just creates a nice transition between them, as if they were merging, right? So this feature is available inside the PNet node. That's what this system is about. So if we go to the PNet node when we're in export mode, we have these options available. So we can set for every layer how it should act if we make a change to a previous layer. So in other words, if we are updating the procedural layer and we have some manual sculpting, some micro sculpting in there, we can tell that sculpting to say keep maximum height. So if we have any overlap between our own sculpting and manual sculpting, it will always keep the highest result. If we want to, of course, not on every option, but at least on the let's say modifications auto mask subsequent layers, that option, if we turn on composite masking, we can also feed a particular layer called composite mask into the system and then use that to drive our override. Basically, anywhere this mask exists, subsequent layers will effectively be erased. So that can be useful, like I said, if you want to push through your changes through any manual changes in your terrain. I think somewhere in here, I was looking for that Houdini logo in the center of my map. Right, this one. If that was in a micro layer and I want to make a road go straight through it, I could use a mask, or I could use the other option, just this option here, modifications auto mask subsequent layers, to simply erase it and then the road to go straight through it. It's basically the gist of that. This can be useful in some cases, I imagine. Haven't had to use it too much yet, but because the way how Unreal layers basically just stack on top of one another, we don't want it to accumulate and then result in some weird deformation where we previously had some micro sculpting or something. Okay, so just to close this off, so like I said, I want to make some changes to the PNet node. One of them is to add asynchronous importing and exporting. This could be support for PNG files or EXR files as inputs for the PNet node. So right now we are basically importing, if I go to the setup, sorry, if I go to, where are you? Right, so at the moment this is disabled because we are in, that's the wrong node, hold on, just go to the top, go here. There. Okay, so we are currently in compositing and exporting mode, and as you notice, there's currently no option available for me to specify a file, right? Unlike this guy, which is in import mode, we can specify a BGO file. In export mode, it only takes an input channel. That's intentional actually, but maybe we want to, alternatively, if we are in import mode, we don't want to import in a BGO file. We want to import in height map layers like these guys, right? So maybe we want to import in the individual procedural layers and the base layer, micro layer perhaps there, right? So if we want to import in these changes, this piece of data, instead of going back to Unreal, applying our terraforming, then extracting it back from Unreal to a BGO file, we could potentially use textures. So that's another change I want to do, where the import process can take textures as opposed to BGO files for both the import mode as well as the export mode, so we can do some things like layer different terraforming together. At the moment, that's not possible. Like, imagine, for example, I want to apply some terraforming to my base layer first, then this is an export node, right? But then we string that together again. We put another couple of nodes behind this to apply it to, say, the next layer, the procedural layer. So we could string together different processes. That's one option. And the other one, of course, would be to extract our data using an alternate method. So the ability to import or export only partial landscape sections, or by using blueprints, for example. So like I mentioned, the method that Alexander pointed out, using a blueprint to export out EXR files and then bring that out to textures that I can then import instead of as a BGO file. I'm trying to streamline this process as much as possible. I also want to hook it into the PDG as well, so it can be as straightforward as possible, maybe even driven from inside Unreal or from on a render farm, so the process becomes less manual and more automated. That's one of my goals. And to that end, there's actually a feature that I didn't know about before. This is relatively new, in that you can use this attribute called Unreal Landscape Output Mode, as well as Unreal Landscape Edit Layer Name, to modify a streaming proxy tile. So if you set it to 0, it will try to create a new landscape. If you set it to 1, it will try to modify an existing landscape, as long as you tell it which edit layer and which name of that, which tile number, effectively, right, you're trying to talk to. And then you need to give it the right height map size for that tile and for that edit layer. Give it the right data, and then it should be able to write into it. Now, I have tried this. I haven't gotten it to work yet. There is an example I was given by Alexander. I haven't gotten that to work yet either, but that might be because he gave me a indie license and I have a commercial license, and the Houdini engine doesn't like that. So I need to test this on a indie license first, and alternatively, I'll just try to make my own version of it in a commercial license, see if that works. But that aside, this is very promising. Something I can do in the future, perhaps to automate the import process instead of having to go to the Unreal import system here for landscapes. This could also potentially allow us to import only to specific tiles in our landscape, even when we have a larger part of the world loaded, but we only want to say update, say this portion, right? That could be useful, because right now Unreal will simply import to everything that's currently loaded. And as far as I'm aware, I'm not even sure if it can even import to a partially loaded map properly. Though, like I said, either it just didn't work at all, or it did work. I have no idea. Let's go and try it out, right? Let me just quickly pull out some other data here from a different tile set. Importing to procedural layer. Click on that, import that, and then let's have a look, right? So this road currently looks like this. This is with my new road winding. This is my new post-processing. I'm working on that. If I import this data on a partially loaded map, let's import that. Let's have a look. It's only going to change the terraforming, not the material. Okay. It does look like it changed it. You see the road now goes this way. But if we were to go to, say, a different part of the map, right, part that we had unloaded just now. Yeah, it did change. I can confirm it changed. But if we go to another portion of the map, let's say where we didn't have it loaded. Now I gotta find that seam again. It's somewhere over here, right? Maybe it should be obvious. Or maybe not too obvious. The question is, did it actually apply it to other parts of the roads? I don't think so. Because this part still seems to be pretty smooth. Let's find some of those fences. It still matches the material. So, yeah, like this is basically the process that I have to go through a lot. I mean, there's documentation, but not on everything. A lot of things actually are not documented properly for the Unreal Engine. So I spent a lot of time just testing stuff out like this and trying to figure out if something works or doesn't. But so far, this looks like it hasn't affected the height map. That's as I was expecting. Now, if we try to find a seam somewhere, yeah, here we go. Okay, well, it seems, and this might be one issue, that our streaming proxies were disconnected. So, yeah, not so much luck as I thought. Right? But that's the main issue, is that streaming proxies are connected together at the seams. And it doesn't seem to properly do a good job about it if we try to import only a partial set of height. I think if I try to like load everything again, or maybe not that part. Let me try to re-import with just this part selected, right? So import again. It's gonna take a second, I bet. It might fix the issue. Yeah, there we go. So, it's interesting, because if I were to sculpt in between these two tiles, it would be flush, okay? But it just seems to me that if you try to import only to a small portion of the height field at the same time, it won't do the proper interpolation between the tiles, and you'll get seams like that. I guess that could be a downside to the same process, right? But again, that's a problem. Another problem we have to deal with. So, I think that's basically it right now. If you have any questions, like, go ahead. I mean, you can use your mic if you have it available. Otherwise, you can type some questions in. Yeah, it definitely took some time. I spent several months just to research how it all worked. Even before then, I had to try and work with standard landscapes, and it was just... There were so many questions I had just on how to import data properly. There's not too much information about it online. But I can say that now I know how it works. I can work with landscape tiles on their own with the right offsets, right? With the right values. I can bring it into Houdini even without this, even without the Master Builds Toolkit. I can import data into Houdini and then render it back out again. So it is possible once you know these numbers, and you can do some terrain data that matches Unreal's data, bring it to Unreal without modifications, and you can also confirm that there are no modifications. It's very simple. You can go into Unreal, export out some tiles, right? Just using the export system. then potentially if you need to composite it together, right? Or you can compare, say, the procedural layer with the procedural layer that Houdini is outputting, and then compare those two. If you want to compare this data, I believe I have an example I can show. Like basically what I do here is I can load, say, a landscape tile, and then I can split out the tile I want. I can convert it to a height field. I can take the same tile from my system, convert that to a height field, then simply do a simple difference check. In this case, I'm just doing a near point. So the nearest point to another point gets sampled. And then find out what the difference is. Alternatively, you can sort them by their point numbers, like use a sort node to sort them by X and Z, so they always have the same order. And then you get a difference value. You can feed that difference value to a ramp node like this. You get negative 0.0001, positive 0.0001, create a nice color gradient like this, and then if it's not making any changes, then you say it's gray. If it is making a change, it's blue. If it's positive, for example, if it's negative, it's red. And then effectively you can find out if your Houdini result is the same as the result from Unreal. In which case, well, I'm not loading the right file here, mind you, but in this case we can effectively test if our modifications are going to cause a difference compared to what Unreal's terrain is outputting. There's a bit more involved. For example, you might have to do some offsets, like I said, depending on if you've made them in Houdini. There are definitely other minor tweaks that I'm making in here to the offsets to deal with grayscales, to deal with the different edit layers. For example, the base layer spans the whole range from 0 to 1, right? This one spans the whole range from 0 to 1, but any subsequent layer is basically a grayscale layer that encompasses the changes from gray to black being half the range down to white being half the range up. As a result, we can only make changes to half the height of our landscape in any subsequent layer. Right, so these three layers can only make half a height field's height change. If I go to maybe the lowest part of my terrain here, it's easy to show. Let's say I go here. Oh, it's locked, hold on. Let's go to our micro layer. It's sculpting, and then if I grab my flatten brush, give it a really high height, let's say a million, I don't know. I try to paint somewhere, right? Okay, I definitely have to use a higher value than this. Okay, if I try to sculpt it even higher, boost this up. At some point, it's going to clamp. Can't go any higher than that. Let's see. There we go. So that's the maximum height. This edit layer can modify this height result. And if we look at it, it's about half the height between these two blue lines here. That's basically the range one of these subsequent edit layers can modify the terrain. So, well, if you guys are good, then I'll close down this particular live stream. I mean, in one of the next ones, say next month, end of next month maybe, I can cover a next topic. For example, basic idea about pathfinding, like for the road system. Yep. Yeah, I'm gonna get a bit of rest tonight. I'm definitely gonna do a bit of resting before tomorrow. I gotta work again. I also want to continue with my masterclass. I do know what I need to do. I don't have too far to go to start recording on the next module, but I'm still trying to figure out where I can get the proper amount of time and rest from, and working on the Massive Worlds tool for the event last month, and then the other work I have to do for my clients. Basically, there's some deadlines that I still have. Hopefully, they will lighten up pretty soon. But even so, I've had non-stop work for several months, and very little rest in the meantime. So I've had very little energy to put into also recording the videos. But I am considering taking on less mentoring. So I have, let's say, if I have to do mentoring for like 2 or 3 hours on a Friday afternoon, right? Then I lose most of that afternoon because I have to prepare. After that, I don't have too much time left before I then have to start, working for one of my clients. So I'm trying to balance my time. And if I do less mentoring, or less days in a month mentoring, I would have more time available. So I'm looking into maybe downscaling my mentoring program to less slots at the moment. And then, see from there, right? But ultimately, getting there, definitely feeling a bit more energetic than I was a few weeks ago. It was fun, but it was very tiring. Anyway, enough of me talking to my microphone. I'm gonna go and have some rest, and I'll see you guys around in the channel, and otherwise in the next live stream, right? Have a good one.